Thank you very much. Seth, if you can, stay on for this panel discussion, if you're available. Um, Katie Martucci is going to be logging in, I
Yes.
think.
But I
And,
have a question.
oh yeah, oh, go ahead.
I wonder about the technical question.
It's a technical
If
question.
we have about the Zoom, so when they speak and if we have our microphone on here, do they hear an echo of themselves or virtual
Seth, could you
them?
talk right now? And do you hear an echo of yourself?
Yes, I do hear an echo of myself.
Okay.
And I am gonna so I will mute when they are talking so they don't hear an echo of themselves.
All right. Merve's going to do something technical on our end to try to reduce that.
I just turned my volume down on my side.
Okay, it sounds good. Andrew Smith's not able to join us, unfortunately. His son has drumming lessons. I asked him to cancel it, but his son really likes to drum, so he's not going to do that. I'll invite all of the speakers from today. So Dario, Gerge, Alex, come on up to the front. And then we have Dr. Katie Martucci from Duke University's Department of Anesthesiology is joining us. Katie, I'll let you introduce yourself when you're ready.
Okay, sure. Thanks, Ken. Yeah, thanks, and thanks, Mara, for inviting me to join the panel. I've been catching on the spinal cord workshop as much as I could between meetings, so it's really great, and I'm so glad the talks are recorded so I can pick them up after. So I'm Katie Martucci. I'm an associate professor in the Department of Anesthesiology at Duke University. And here we have the Center for Translational Pain Medicine. So it's a bunch of chronic pain researchers that all work together in the same building here at Duke in the anesthesiology department. And I do mostly, I do a lot of brain imaging, but I also do spinal cord fMRI that I worked with Ken at Stanford on my first spinal cord fMRI studies. And we mostly look at patients with fibromyalgia. So we compare patients with fibromyalgia versus healthy pain-free controls to look at resting state activity in the spinal cord.
Here, any questions for the panel? I guess give a little bit of overcap on what we did today. We started with lumbosacral imaging. We talked about advanced shimming and the shimming toolbox, applications in traumatic spinal cord injury, then multiple sclerosis, and we didn't have a specific talk on pain, just to scheduling limitations, but Katie's definitely has that space, and I guess also sort of changes with opioids, right, as well, with resting state activity. Questions for the panel? Great.
Yes, maybe I'll follow up with a question that I had asked during lunch, or it came up during lunch, which was the variability for the same subject. Like if we were to basically, image them day to day or over time, what kind of variability have you seen, like within the same subject, in terms of if they're doing the same action? Do you see the same activation, say in the dorsal horn? And then also from that, kind of how do you interpret if there is variability, if that's from a more technical side, or is interpretation more that there's just variability in the cord over time, depending on the state of the person?
Yeah, that's a good question. And so describing the problem once again. So with the electrical stimulation, we did the same. It's a very controllable task, right? So same amplitude above the motor threshold, same frequency, and we repeated the task after 7 days, right? Same day of the week. We told the participants to follow the normal routine, right? So that if they, I don't know, drink a coffee every Monday morning, that they should do the same the next time. And yeah, but we still observe that the subject level results are very variable. I didn't show the electrical stimulation results subject level, but it was the same. So the variability is both in terms of the amplitude and the location. I mean, there is also like a thresholding thing, right? So that you can, if you threshold it maybe differently at a different statistical threshold, z value, then the pattern might look similar. But I mean, you can see, so two things. So you can see, even if the results are variable, you can see certain trends, right? So that the activation pattern appear on the ipsilateral side, and the amount of activity is above the false positive rate. So it seems to be driven by the task. Yeah, but we can only speculate about the reasons. It can be the vasculature, both in terms of anatomy, but also the physiological part in terms of blood volume, baseline blood volume, blood flow. And I don't have the answer. I think we really need to go back to animal studies where we can monitor some of these things: blood volume, blood flow, CO2 level. With that answer your question. Yeah. Yeah.
Follow-up question, Kerrigan, because you said you determine the motor threshold and then you have a certain amount above the motor threshold.
Yeah.
You determine it on both days, I guess. This could be different, right?
Yeah,
Slightly.
yeah, but so the motor threshold in terms of milliampere, it was not significantly different. So it was, in fact, it was very similar on both days.
Well, thank you so much for the amazing talks. Actually, I would like to hear every panelist's opinion on this, especially who are doing clinical imaging. So what do you think, what would it take for this advanced, like more fancier imaging sequences to get into clinical protocols? Imaging sequences and methods as well. What do you think would it take? And I have a second question. Sometimes, of course, we have these methods, and then the correlates with behavioral metrics might not necessarily be the best, or they are maybe sometimes moderate. Do you think, is it in the side of imaging? Do you think imaging should be better? Do you think our metrics, behavioral metrics, we correlate with are too general and maybe we need more specific behavioral metrics? Or do you think, is it the complexity of disease that we are not able to capture the whole disease with this relatively simple, not simple, but relatively like one-dimensional metrics?
Yeah, I guess who's gonna start?
Yeah, so I think one of the problems is that we don't really have normative values for some of these advanced metrics. So, for example, if the patient comes in and you measure DTI, and you have, if there is no visible pathology, right, normal appearing white matter, you can, and you measure an FA value of 0.6, right? Is it, with what confidence you can tell whether it's pathological or still normal, right? It depends on so many things. It depends on the sequence you use, the scanner, and of course, in a longitudinal design, it has value because you can compare it to the previous measurement. You can see that the change, but just telling based on a single value whether it's pathological or not, unless it's like a really outlier and it's obvious, that then it's very difficult. Yeah. So I think that's one of the points. Yeah, but there are other points: retest reliability. We have to make sure it's high enough. Yeah.
Yeah, I can weigh in for the fibromyalgia patients that we see. They, at this point, we're still doing group averages, right? So I'm taking like 20 patients with fibromyalgia versus 20 controls, and that's where we see a difference in the resting state between patients and controls. So I think, Mervit, I think it's more for at least for fMRI, which isn't necessarily like a fancier sequence, but we need the sequences to advance so that we can get them to be more precise, more specific imaging so that we can look on that individual level. And I think that might get to kind of like the just the, you know, basic, like the physicist creating newer sequences that can pick that up. So I don't know how long that's going to take, but that's my non-physicist perspective on it. So we need to get it individual, at least for fMRI.
Yeah, I have a couple of of comments on that. I think I'm sort of ruminating a little bit on Julian's question a minute ago, and I think the question is like, are all of these methods that we're developing, are they necessary to be incorporated into clinical standard of care? And I think, the question is, what will it take to get it into clinical practice? And I think maybe the question is should all of these be in clinical practice? For the reasons that we just talked about: variability, reliability, difficulty, not able to do it at every site. But here's what I'll propose, is that implementing the most advanced sequence that we have currently available on an academic research scanner in a clinical setting, in a clinical population, is extremely hard. But taking the lessons learned to get to the advanced imaging methods that we have gotten to, there are leave behinds there that can and actually do impact improvements in clinical imaging. So I think in some ways we see some of the better imaging that have come from pushing forward on some of the techniques. We see some of that better imaging in the clinic now, but they're not that super advanced multi-shell, multi-direction diffusion scan to get access to the neurite density or things like that. But we've gotten better at imaging with diffusion over the years, and I think we see that incorporated somewhat in clinic. So I think there is some stuff there that's been learned from some of these advanced measures, but I'm not really ready to say that we're going to take the most advanced tools that we have right now and put it into the clinical workflow.
Quickly on the maybe acquisition side of things, I think, well, we're doing our best to improve the image quality, but I think, where it sticks is like the more we improve things, I think it's going to get picked up more by the community, and then once more people use it, then it gets picked up by the vendors, and then once that's done, then it's available more widely. So yeah, so reflection.
Yeah, I'm trying to answer both of your questions at once, if I have that correctly in mind. First of all, it's hard to change structure systems, I feel. Even now in SCI, where like a conventional scan that they already do, even that is like is already available still, like having these like morphometric measures implemented, it hasn't happened yet, even though there's strong evidence. It needs to be fast, it needs to be easy for clinicians. Those are two main points. And then you asked about whether like the simple measures are enough. I think now with some collaborators that we're working on in DCM, Ken and I, we're trying to come up with like composite scores, capturing different dimensions or aspects of like intermedullary lesions. This might be something else that could be beneficial. Yeah, some composite just has to be easy and quick.
Maybe a bit as a follow-up question, if you can comment on interpretability of these kind of more advanced metrics that you get from like quantitative MRI or all of the things.
Could you clarify a little bit what you mean by interpretability?
Well, understanding what these metrics mean. For example, just Dario, you talked about a composite score. Do you think something that's maybe refraining some of these to get into the clinic is the understanding of the meaning of these metrics?
I think that's one point that kind of limits the implementation in clinics. Yeah, you first gotta show and be sure what it means. And having composite score doesn't make that easier. Yeah.
Yeah, I think one thing that I'd be interested in, is, we had there's a human connectome project for brain imaging, and Sandrine's working on this, Merveillard, but we're trying to work on normative modeling of some of these spinal metrics so that we can try to make individual level inferences and know where somebody deviates from normal. But the challenge is that a lot of our open data sets, they're a lot younger than the population we're interested in. And it'd be great to get, I don't know, somehow a bunch of money so that we can do large multi-site studies and put it all the data together. But yeah, I don't know that, or just some crowdsourcing. I don't know, Julian, if you ever thought about, or we could do more of the generic acquisition protocol and try to get people to image older people and crowdsource across some research sites. I don't know. Maybe we could do that. We'll do it, but we need other sites as well. I don't know. Just a thought. Yeah. Any other question? Yeah, Julian.
I can comment on that.
Yeah.
I'll quote Seth. It depends what you're looking for, because the thing is, we could, instead of 267 participants, we could have 10,000 participants, and then what? We'll still have the same variability across vendors, and then in 3 years there's going to be new models, new scanners, new sequences. I'm not exactly sure how we can leverage this. And I really see two avenues that we are a bit struggling. Struggling with. We are kind of we are hesitant. Because on the one hand we are doing research and we are developing all those biomarkers. And as Seth said, for example, there is, and I agree with this. There is a value for advanced QMRI techniques to look at, for clinical trials, to have objective biomarkers. But this is not a clinical routine. This is different. So, there was a question 5 minutes ago about, how do we make, these techniques into the clinical routine? And I'm not sure if it's a good idea and what technique we should put in. And in fact, I mentioned that I think 2 days ago, but I was a couple of weeks ago. I was visiting a radiology like a clinic, and I was talking to radiologists. And the purpose of my visit was to implement some of the span generic and new techniques into their service. And I was talking with them, and I was like, "What do you need? What could be improved? Can you show me your protocol for SCI, for MS, and so on?" And they were like, we're pretty happy with what we have. We have our T2 sagittal, and then the axial, and the medic for MS, and we don't need more. And they have been used to that, and they have been improving that over the years. And yes, there is, Dario, the amazing work that you're doing with Jan about, getting numbers. And you are saying, yes, there is strong evidence that these numbers are relevant. But, I also believe that radiologists have those numbers in their head. They come up with those numbers because their years of experience, they're just, it's like a Bayesian model in their head where, they've been seeing those images for years, and they just come up with a, fairly accurate, diagnosis and prognosis, and that would, then lead to some particular intervention. Yes, there is variability, but as we said, there is also variability in the imaging and in those quantitative metrics. So, it's a fairly pessimistic view about, how we can implement that. But I think the general conclusion of my statement is that into the clinics, I would say we should improve fast. I mean, I'm just going to repeat what Seth said. Essentially, just improve, efficient, fast, simple imaging, tackling on low-hanging fruit, which is shimming, better coils, better hardware, and then for advanced research, clinical trials, continue to investigate and maybe find potentially relevant biomarkers. So there's still job for everyone in the room.
follow up. And what about just using these tools to have better understanding, more in creating scientific understanding of those pathologies or neuroscience and
Great comments. And, we've been trying to a little bit to try to get some of these more advanced techniques in Stanford's clinical practice. So far unsuccessful. But if we could, then, then we can get lots of data. That's what hopefully we could do. But one thing is Seth, you showed some just the use of the MEDIC merge sequence for identifying the lesions. We've been able to download all of the MEDIC data from Stanford Healthcare, at least people with neck issues and back issues. And most of the quality of it in general is quite terrible looking, which is surprising. But I don't know on your end, have you used any additional techniques for the multi-echo, gradient echo imaging to make it less susceptible to motion? Is there a way to speed it up? Could you do, I don't know, is it possible to do reduced field of view imaging on those kind of structural scans? I don't know, I'm just throwing out ideas.
Yeah, it's a great question. So what I didn't spend a lot of time talking about is that Kristen O'Grady has been wrestling with this a lot, trying to image in the thoracic and lower thoracic. So, we have to take some lessons from our cardiac imagers, frankly. They're able to image the beating heart pretty well. And, things like navigation and respiratory navigator and all those types of things that they use. Now suddenly your super high resolution spinal cord scan becomes 18 minutes long. So there has to be some thought put into how to achieve that. But I think it's a great point. The MEDIC sequence looks really great when it's done in a fairly easy area. And it looks really, really bad when it's done in a very difficult area. I think that's the way it is. So it's a great point. Can we make it more robust? The challenge is that at its root, it's a multi-echo gradient echo. So you're going to be susceptible to all sorts of breathing artifacts, changes in susceptibility, those types of things that you don't necessarily get with a spin echo. But when we run into the spin echo, we find out that a lot of your tissue relaxation times aren't as distinct as we would hope. So your contrast isn't as great. So I think there's a lot of work to be done. Kristen's had a lot of success with navigating the MFFE. It's a little bit longer, but you get rid of a lot of the breathing artifacts and it looks pretty good there, actually. Increasing contrast with magnetization transfer preparations, where we can sort of highlight the spin density differences between gray matter, white matter, or lesions. Also helps with contrast, but not necessarily with image quality. So great point. I think there's a lot of work to still be done with standard, I shouldn't say standard, but a lot of work to be done with clinical type imaging sequences to make them better than what they currently are.
We also found on our Siemens scanner that a navigator readout helps a lot with multi-echo gradient echo. So basically we sacrificed the last echo for a navigator echo, and we use Johanna van Nestio method. Basically it uses a custom readout or a custom navigator processing. We also found that in some of the difficult areas of the spinal cord, the standard navigator processing of Siemens actually makes it worse. But with a custom navigator processing, we can improve the quality in those areas as well. And the other small improvement that we used, or a small trick that we used, is that we switched to from MEDIC to a GRE sequence, which gives out the echoes separately. So it doesn't combine them on the scanner. And in some cases, you can, if you look at the first echo, second echo, or only combine the first two or first three echoes, then the quality gets better because you exclude the later echo times. And it gives you a lot of flexibility combining different amount of echoes.
On the Philips scanner, all the echoes are exported individually, so that was something I wasn't aware of on the medic sequence.
Yeah, Medic already combines it for you, which is, I think, a
Is that
disadvantage.
true for merge as well on the GE?
For G, I don't know.
G tends to not give individual echoes for most sequences. Yeah, there's a CV you can change manually, but it's really random.
Hi. Okay. I guess for background, I'm so saddened to hear how pessimistic we are for implementing all of these procedures into clinical care, because I do all the recruitment for our studies, and I recruited like hundreds of fibro patients, and they're so excited to see this research trickle into their clinical care. They want more, they want better scans, they want more knowledge, they want more research. So then for us, what's the goal? How do we advocate for this research being implemented into their care? Because it's so cool to see all this research being done. Also, I have no PhD. So like, explain this on a baby level, like, right, how are we taking this and then pushing it forward? Because I know doctors are very resistant to change, but they have to change, right? Because like, we're coming up with new techniques and new things. So like, how do you guys, like the big brain people of the world, how do you push this forward?
I mean, I can speak, so my studies are in fibromyalgia too. And I think the main way that we can, I mean, for fibromyalgia especially, it's this widespread body pain. I don't know how many people are familiar, but cognitive dysfunction, fatigue, all these things. So if we can just find, and it's the etiology is fairly uncertain. Like, we really don't know. We know it's a central nervous system disorder, but we don't know how much the periphery contributes and what all these different, how much psychological factors contribute. And it's probably different across different patients too. So I think just doing these studies in these types of patients helps at least to show that there's something different in these patients than people who don't have these chronic pain conditions, to validate their experience and validate that, yes, you do have a chronic pain condition. Even if we can't see it on the individual level, we can still see the group level, that there's something different. And then we can take that knowledge and try to come up with, how does this inform new treatments? Like, what should we be targeting to change these signals that are different from our fMRI data or MRI data that we're seeing? I mean, Dario, I think it's really cool how you're planning to look at the structural differences in fibromyalgia too, because I think that would be very clinically relevant if you can see that, if there are actually kind of undetected structural, you could, I'll let you speak to it, but that clearly has. So there's lots of other little ways forward, not with us needing to do really fancy scans on all these patients that are going to be really expensive necessarily. We can do all this work and just gain understanding, and slowly, and it will trickle into the clinic, I'm sure of it over time. Yeah.
I think I can only echo on that, Katie, and also add, we're not at the forefront of helping these patients immediately. Not even, most of us, not the ones running clinical trials, which would be like a step closer. We're really trying to improve the mechanistic understanding. It can seem, or is a bit far from direct benefits for patients, and it can seem depressing, but like our discussions here, like acknowledging what we can do, what we cannot do, and what we know and what we do not know, is already like the first step towards improving what we're doing, I think. Yeah.
Yeah, I think Katie's points on chronic pain and fibromyalgia, it's different than traumatic spinal cord injury or multiple sclerosis, where we have, there's sensory deficits, motor loss, issues along those lines. But in fibromyalgia, it's validating. Your research is validating that there is underlying changes in the central nervous system. Dario is starting to do some structural analysis. Katie recently showed some evidence of gray matter atrophy in fibromyalgia versus healthy controls. So, I guess it provides hope, but then also targets to hopefully improve the management.
Yeah, I think one quick comment that I have, it sort of stems from your comment a moment ago about how pessimistic we really are. I think that maybe is not is not the case. I think in order to be able to sort of build the road or lay down the road of change, sometimes you have to go further and further into the weeds to sort of clear it out. And I think that the encouraging, I give a lot of advocacy talks to the MS patient. They want to know, like, when is this stuff going to actually change my diagnosis or change my clinical course? So it's a similar question. And the advancements that are made in the research setting will precede changes in clinical care by a significant amount, but that doesn't mean that there aren't changes coming or that there are changes available or there are changes. We may sit here in 10 years and look back on even this conversation and say, wow, look at all the changes that have happened because of pioneers like yourselves going into and sort of blazing the trail to be able to lay the foundation for the next step of the advancement. So, yeah, I wouldn't cast it necessarily as pessimism. I think it's just, do we have the advanced tools right this second to drop onto a clinical scanner in a rural hospital in West Virginia and use that on 1,500 patients? And I think the answer is no. But are we making advancements that 10 years from now we look back on and say, wow, look at all the accomplishments? I think that's the encouragement to the patient, not necessarily what we're doing at this moment.
I have a purposely general question we've covered a really wide range of topics, and obviously everyone here is very focused and specifically interested in spinal cord neuroimaging, but to solve a lot of these really complex scientific and clinical questions, we obviously have to look outside of only our specific imaging modality. So I was wondering if any of you have an example of how you've worked with someone, a collaborator or a colleague in a completely different field that helped change the design of your study or consideration of your study in some way.
Yeah, I guess, from obviously I do shimming, and the optimization part of it, I was looking at, well, I took a class about, optimization and black box optimizations. So the idea of doing an optimization instead of just, doing the whole F and Z that I was talking about, that came from taking that class. Aside from that, I'd say, I also do some work in the brain, so looking at the brain as well. That's my 2 cents.
Yeah, I think it's good to think about these things and foster collaborations. I could mention a few, but thinking like further outside of my field, I think what we often miss in specifically talking about clinical applications is talking more to animal researchers, basic scientists, and trying to figure out how we can do better with regard to translational research. Yeah, I think that's what we could do better.
Yeah, I can comment a little bit about some of the knowledge gained from outside. So when I first came to Vanderbilt, I was an MRI physicist. That's sort of what I knew and it's what I was comfortable in. Did some clinical translational imaging. When I came to Vanderbilt, they asked me to teach a course that's a survey of all imaging modalities. And I had to walk around and spend a lot of time learning from a lot of other people about why use this modality, why use that modality, what's the sensitivity, specificity, what are the weaknesses, pros, cons, all that. And that sort of spurred a larger and larger conversation to learn more and more about what others are thinking about when it comes to trying to assess various aspects of various pathologies in the clinical setting. Sometimes imaging is good, sometimes imaging is not as useful. And I think that there are opportunities to, I guess, sort of to a comment to my old younger self, is to not turn a deaf ear to conversations that may seem out of your wheelhouse, because you learn from that, you gain knowledge from that. I've always been impressed by the cardiac imagers, for example, and how they can image something that is a beating heart. And I complain that the spinal cord moves a millimeter here or there. There's so much to be learned by those types of, not even necessarily collaborations, but just relationships, coffee conversations. Think about the way that they see things and the challenges that they face, and maybe there's some insight that could be gained there. So that's sort of a general answer, but oh my goodness, the scientific community is so rich with opportunity to learn from others.
I guess my comments on this is that, and you kind of already know this, Joel, but I did so much manual segmentation of the spinal cord that so much time, weeks spent coloring in spinal cords that led me to learn computer vision techniques so I could develop my own models to automate it, and then have applied it now in muscle and no longer have to manually segment muscle. But just in the last month, someone reached out with a stomach. They need to do stomach segmentation. Yeah, sounds great. I'll help you do that. And the one neat thing that I'm learning from this is the stomach is a completely different problem, I guess, and a task than the spinal cord, and that they're doing it on an empty stomach, and then they eat a big meal, and it makes their stomach twice as big. Its shape changes, and the food passes through the stomach in different ways. So it's a completely interesting a new problem that should be fun to try to solve. And then just 2 weeks ago, we're now also going to look at uterus segmentation as well. So I don't know. Never thought I'd be doing that, but it's pretty cool.
We also learned a lot from me and all, yeah. Beautiful. Yeah.
Yeah.
Thank you so much for the. Oh, sorry. Thanks so much for your comments. I guess I'm new to diffusion MRI, but I see a lot of diffusion here. Diffusion acquisition seems to be standardized to some extent, but what about processing, pre-processing? I've noticed that the same data set can yield 2 different results in 2 different papers. So any comments on how you're standardizing diffusion MRI, diffusion kurtosis, or IVIM effects as well?
Yes. So I think there is already some consensus about the steps that need to be taken: denoising, motion correction, for the brain susceptibility correction, which the method you use, there are like different opinions. I mean, in general, I think it's more important for you to do these steps. That's, the differences between different softwares is probably less than whether you do it or not. Yeah, so that's one point. So I think we already have a good idea of what also what in terms of the fitting, how you fit the diffusion tensor. We have some understanding that, okay, it's better to use, for example, a robust fitting instead of the traditional OLS fitting. Yeah, so that's my point. Maybe Seth can also add some additional points.
Yes, Seth had to drop off, but he says thank you and great job. Additional comments? Okay. All right. Thank you, Katie, for being here. This is an excellent conversation. We will end the panel session.